Good day, everyone. Welcome to another segment of Online iCode Tutor. Today, we are going to continue from where we stopped in our last class. Now, that's different connectives in logic. Now, the third one is conditional. Now, when we are talking about conditional is something as if, then, and also refers to as implication. Now, when we are talking about implication is a logical relationship between two statements where the truth of one statement follows from the truth of another statement. In logic, implication is typically represented by the symbol arrow. When you have symbol, it denotes implication. Like one sentence implies another sentence. That P implies Q. Now, that means that if, let's say, we have as an example, let's say you have a sentence. If I have 3 cookies, then I can share with a friend. If I have 3 cookies, then I can share it with a friend. Now, if you look at it, these sentences contain if and then. If I have 3 cookies, then I can share it with a friend. Now, if you look at these sentences use if then to show that having 3 cookies allow for sharing with a friend. That's a typical example of P implies Q. Now, the logical representation of this particular P implies Q is, let's say, in a truth table. Let's say you have P and you have Q and you have P implies Q. Now, the normal representation of Q is T, F, T, F. Why this one is T, T, F, F. Now, in terms of implication, when you have both true, T, T must be true. Now, and also, what we are going to note is that where this arrow facing Q, it faces directly Q. That means that for you to have a truth values, your premises on Q must always be what? Be truth. That means that this our FT also will be true. That means that order will be false, a false statement. That means that 1, 2 things are involved in terms of the truth table of conditional, which is implied. The first thing that's involved is that both your sentences on P and Q must be true for you to have the response of true. And also, where the implied space are on Q must also be true for you to have the truth response, while others will be false statements. Now, the last one is biconditional statement. From biconditional statement is something as if and only if, which is something as equivalent. Now, biconditional statement is a logical statement that is true when both parts have the same truth value, either both true or false, and false otherwise. Now, let's say as an example, maybe having a triangle is equilateral. A triangle is equilateral if and only if it has 3 equal sides. Look at that statement. Look at that sentence, I mean. A triangle is equilateral if and only if it has 3 equal sides. If you look at the sentence, it has what? If and only if. If and only if. What is that if and only if? That means that they are talking about what? About biconditional. Now, the simple representation of symbolic form of bind conditional is this. That means that P, we call it equivalent, P equivalent Q. Now, the simple representation of this on a truth table is P, Q, P equivalent Q. If this one is T, F, T, F, this one will be T, T, F, F. This one is single. It as if they are talking about equal. If you look at this, T and T, are they not equal? They are equal. T and F, are they equal? No, that means that it's false. Are they equal? False. Are they equal? Yes, that means that this is how biconditional is being represented in what with a what? A truth tables. Now that is all about this particular topic on conditional and biconditional under logical statement. Now let us stop here for today. If you have any question, please kindly let us know from the comment section.